as Fernando said, yeah, I'm Michael Southcott. I'm here from Standard & Poor's. Yeah, over the next sort of 30 to 40 minutes, hopefully to give you a good overview of where the landscape is on the electric motor market for what we consider to be light duty on-road applications. So that is anything up to 6 tons, so covering passenger cars up to some light commercial vehicles as well. So in terms of a bit of an agenda, I will spend a few slides just introducing Standard & Poor's and who we are and what we do in the mobility space for anyone out there who's not sure where we operate and what we do in this market. Then we'll go through an overview of the electric vehicle market, a few slides as to where we think we are today and where we think we're going to move towards in the future at a top level. And then we'll move into the real in-depth part of this, some of the drive technologies that are coming, their impact on motor design, some of the critical parameters within the motor that tier ones and OEMs are looking at and their importance in the wider vehicle. Then, as Fernando said, a little bit around the critical materials, some new research that we're launching there. So we'll try and do a bit of an assessment on a couple of the materials that we've initially tried to give an assessment on in this space. We'll look at how the supply chain is going to evolve here. So particularly around where we think tier ones are and tier twos and tier threes, and also the OEMs are going to fit into the complete supply chain of this, and how, flexibility is going to be a word I use quite a lot on that, particularly relevant for the suppliers, and then a very, very brief summary at the end. So let me please just quickly go through who we are at Standard & Poor's, or S&P Global as we're called. So the key bit here is in the bottom right. IHS Markit is now a part of S&P Global. So this is, for those, a lot of people are still know us as IHS Markit. It's traditionally who we operated in this automotive space. 2 years ago, we were purchased by S&P Global, and we fit within one of these 5 divisions. We fit in the one in the top right there, S&P Global Mobility. So within that, I work within Automotive Planning Solutions, which is the wider division, and then I work within Supply Chain and Technology. So who are Automotive Planning Solutions? Well, you can see just some of our credentials here. I won't run through them all, but you can see we work with 100% of the top automakers, same on medium heavy commercial vehicles, same on the supply chain. We work with, approaching 1,000 automotive experts we have on the ground. We have 100% coverage of global long-term forecasts, and that covers the component level as well. So just some of the quick statistics on that, on the vehicle planning solutions as a whole. In terms of where I sit, supply chain technology, this should be updated this year. This is now well over 100 analysts in 18 offices. You can see on a monthly basis, we update about 30 million rows of data at a global level, and that covers 15 vehicle domains there. So I lead the propulsion service we have, but you can see if there's any interest you have on any of these domains, please do reach out to us, covering anything from autonomy, battery charging, right through to thermal management, or materials, and you can see them there. So quite a vast array of what we cover. So as I say, if you do have any interest beyond e-motors, please do reach out to us to get our insights there. A quick one from my team. So this is what we track around what we call the propulsion value chain. So this is really what we're going to focus in on today. I'm not going to cover the inverter just because of the audience that we have here, really more around sort of specific to the motors. But we have all of these fields published in our forecast. So again, when you get access to this afterwards, if any of these are of interest to you and you want to see how the market is going to evolve on any of these topics or multiple of these topics, do reach out to us, do get in touch with us, and we can point you in the direction there. So that's the introductions. Like I said, I try not to spend too long on that. I think it's just good to set the scene on who we are and what we can offer. So let's touch on the growth of the electric motor market and the growth of the electric vehicle market. So where we sit in 2024 this year, we believe just over 89 million vehicles will be produced globally this year. And we can start to break that down. So we think just shy of 40% of those 89.3 million will require some form of an electric motor. And you can see the breakdown of that on the right. About just shy of 23% will be some form of hybrid vehicle. So right from a simple 48-volt BSG system upwards of a full hybrid, Toyota, or even a full plug-in hybrid P1 plus P4 type system. 17% will be full battery electric. So the growth of battery electric into this market is coming. We think it's going to grow again this year. And you can see the breakdown of numbers there. China leads the way, just shy of 60% of all battery electric vehicles produced this year will come out of Greater China, 20% out of Europe, 10.5% out of North America. Two markets, though, that in the next coming years, we think are going to grow in this production. So let's jump forward. 2034, where do we get to in 10 years' time? We've reached 100 million vehicles being produced globally, 100.3 million vehicles produced in 2034. And you can see that jump. The electric motor market is going to see substantial growth, 83.7 million, and it's not far off a one-to-one relationship there. So about 84 million motors at least, or 84 million vehicles will have a motor. We think that there will be at least one per vehicle, in some cases two, and we'll go through that on the next slide. Breaking that 83.7% down, hybrid shares remained comparable. About 20% of the market we think will still be some form of hybrid, but it's the big substantial growth in electric vehicles. 63.4% of vehicles produced in 2034 will be full battery electric. Breaking that down again, you can see the lead region for this production is still Greater China, but that share has come down. Europe is now up to 25%. North America approaching 20%, and China just dropping below 40%. So still leading the way in terms of the volume of vehicles being produced out of Greater China, but we think that that share of the full battery electric market being produced there is going to come down in the next 10 years. So what does that mean for the electric motor market? So what we're here for, as I said, 84-ish million vehicles being produced with an electric motor fitted to them. That translates to over 120 million electric motors being produced by the time we reach 2035. So that is a growth of about over 300% from where we sit last year in 2023 to where we're going to get to in 2035. The eAxle market, so P4 applications as it's traditionally known, will drive this. In 2023, we think it was about 37% of motors produced globally were for use in an eAxle system. By the time we get to 2035, this has grown to over 2/3 of the market, so just shy of 70% by the time we get to 2035. For those non-eAxle motors, so anything that goes into a hybrid system, so P0, P1, P2, etc., we think peak production of that is coming towards the end of this decade. At the minute, we think it's around 2028. That could fluctuate one way or the other, 27 to 29. But that's going to peak at just over 46 million units for what we're classing as non-eAxle motor production there. So the technology that's emerging and the trends that we're seeing within the design from OEMs and from the tiered supply chain. So integration is one of the biggest topics we get asked around. How do we see this market moving? Where we stand right now is we currently track within my team 2-in-1, 3-in-1 systems. You can see on the right here, 3-in-1 system is now pretty much firmly established in the market. It's only going to grow even more. By the time we get to 2035, we think at 83% of the market, and I wouldn't be surprised if we end up seeing that be more than 83%, will be at least 3-in-1. I emphasize the word there, at least. We are now planning to go beyond this, and I'll give you a reason why on the next slide, to look at systems with even more levels of integration here. So we're talking power electronics, the DC-DC converter, the onboard charger. We're talking potentially thermal management, such as heat pumps being integrated into this, battery management systems being integrated. If we switch to Greater China right now, you can see on the market BYD with an 8-in-1 system. So we do expect a trend over the next 5-10 years of ever increasing levels of integration. I think that will vary by supplier. I think that will vary by OEM, depending on the design choice that the OEM wants to take with the eAxle and the level of integration that they want to account for and the space that they have within the vehicle. You know, if you take a look at a 3-in-1 versus an 8-in-1 system, it's pretty substantial, the size difference between those two. So have you got the ability to package that 8-in-1 system, let's say, or is it better to have a 3-in-1 and fit some of the power electronics and these other components somewhere else in the vehicle, utilizing space elsewhere? I mentioned there's lots of people working on this. We've tried to just condense this down for the purpose of this into three of the bigger OEMs that we're seeing on this. I could have produced a list that was endless around suppliers and OEMs working on this. So the top one, Nissan, producing their X-in-1 electric powertrain. So at the minute, 3-in-1. They've also got its 5-in-1 powertrain. So they're trying to produce this on a common platform where they can easily scale this up. Schaeffler, which is an interesting one. So generally the approach that we're seeing on a wider market scale is for integrated power electronics. Schaeffler in their 4-in-1 system, which is out there. You can go on the website and see it. They've integrated what they consider the thermal management system. The element there really being the key one, the heat pump. So they've integrated the heat pump onto their eAxle systems, and you can see there a lot of gains in what, as they claim, less energy losses, unnecessary hoses, unnecessary cables. So quite critical to the motor moving forward is the cooling performance that you can get off the motor and on the wider system. So in Schaeffler's case, integrating the thermal management system. For Valeo, they've gone down the power electronics route. So Valeo are upwards of a 6-in-1 system that they've announced. And you can see there, motor, inverter, transmission, but then onboard charger, DC-DC converter, and power distribution unit are now in this one single unit. The performance, you can see there's not much of a difference. They can scale this from 40 to 300 kilowatts, compatible with 4 and 800 volt architectures. So it's a trend that we're seeing a lot more from OEMs and from suppliers, and one to keep an eye on as we move forward, how many more components some of these suppliers can integrate into this system. So let's move on to some of the a little bit more technical in terms of the motor and the technology trends that we're seeing on there, and the key buzzwords that are about in the industry at the minute. So specific power, or power density, as some people may want to call it. We're seeing a real trend to improve this and a real desire to drive this forward. One of the big reasons and one of the big things we're seeing is the mass of the motor being driven down, the mass of the system trying to be driven down. Some are going in a different route. Some suppliers are going down the route of we'll keep the mass the same. We'll come up with other ways to increase the power. But I would say definitely a trend to reduce motor weight is certainly something that the OEMs and suppliers are doing. So you can see on the right the data here of published data that we've managed to get of 12 suppliers and the specific power. Each, from Gen 1 to Gen 2. This isn't saying that this is Gen 1 of every supplier and this is one generation to the next. There's a step up. It ranges from about 20 to 40%, the step up in increase from one generation to the next of specific power that these suppliers are able to gain now. If we break it down and focus in on just one supplier who has 3 different motor types here, so externally excited, or current excited, as some people may know it, induction motors and PMSM, permanent magnet, you can see the gains that are being made here from Gen 1 to Gen 2 to Gen 3 for this supplier. In particular, the one that I'd like to focus on, particularly being here in Europe, is the EESM machine. That's an approach that BMW and Renault are really in particular driving. Massive gains from Gen 1 to Gen 3 there, to the point that we're approaching PMSM levels of specific power on their EESM machine. EESM is really a technology, and we'll go through that a little bit later. We're seeing real traction now in this market, real desire from suppliers to develop this machine and see where it can fit into the market. Sticking with specific power and how we think, again, it's emerging through the supply chain and through the different motor types. So focusing in on 3 suppliers on the left, and the different ways between induction motor to PMSM that they're doing it. And the different ways in which you can see the mass versus the power. So in supplier 1's case, PMSM weighs a lot less in supplier 1, PMSM weighs a lot less. In supplier 2, you can see there's a bit more of a balance between the mass of the motors and a shift in the power. So just trying to give you an idea or a bit of a flavor of there's a lot of different approaches here in terms of reducing the mass or coming up with other ways to increase the power. And then the power trend that we're seeing. So there's always this sort of traditional line here. There's a straight line you can see going up to about 150 kilograms for 300 kilowatts of power. But we're now seeing the market trying to push that, and we're seeing it trying to squeeze that, particularly you can see on the PMSM machines. And we're seeing a shift. we are moving more towards the right. So reducing the mass, or at least maintaining the mass of the motor, but the power is then coming up. And it's something that we're seeing more and more suppliers do this, and we're seeing more and more of a trend towards increasing power and reducing mass, or at the very least maintaining the mass of the motor for increased power. Some of the ways in which they're doing it. So some of the technology. So this is some new research that we launched at the end of last year, tracking the winding types within the stator. So here's the 6 different winding types that we're tracking at a global level. So we've got insertion, the sort of, the round wire as it's sort of inserted. It looks a bit messy. It's the one that's most common, certainly in the past on eAxles. We've got hairpin, which is seeing significant growth. Continuous wave, or S winding as some know it. So something we've got our eye on maybe more towards the end of this decade into the next decade. Concentric spool, more of a hybrid technology, but we have seen the odd application. I pin, so the single straight line bars, and then X pin, which is something that we've seen from UAES be launched this year in Greater China. We've got our eyes on it. Do we think it will emerge from the Greater China market elsewhere, potentially? Or how big do we think that could become within Greater China? Because as we saw earlier, the size of the market there means that there could be some real growth in this technology. So let's break these down, and we focused here on insertion, hairpin, eye-pin, and continuous wave. So why do you switch between these, and what's the real benefit? So you can see here, and the buzzwords that we've got: efficiency down here, power density as well. The 2 big technical drivers that we think there are on the motor at the minute. And you can see continuous wave and hairpin are the winners on those. The efficiency of the system you can get, the power density gains that you can get. And that's why we think we're going to see substantial growth in those. Technological maturity, you could probably argue that hairpin is now at a 5. We've seen enough. There's maybe some delays in getting some of the production lines up and running. It can take a little bit of time, but I think the technology is there. There's a cost advantage to insertion, certainly on the tooling and the machinery and the manufacturing side. Again, maybe there's a bit more of an advantage on some of these, but I think the key 2 are those technical parameters at the minute. Anything that the motor can do that drives the wider vehicle system, and when I say that, we are focusing there on the battery. Anything that you can do to gain efficiency, gain power density out of the motor that can drive you either increased range for the same battery size, or equivalent range for a reduced battery capacity, therefore reduced battery materials, therefore reduced battery cost. The motor designers are going down this path, and it's going to be something that we see for the next few years at least, while we wait for battery costs to really drop and become something that then the motor cost is factored into it in a little bit more of an analyzed way. It's not to say that you can just spend and spend and spend on the motor, but I would say there's a willingness at the minute to put a bit more money into the motor, because if you can gain the overall system reduction cost by reducing that battery cost. So where do we think this is going to go? Winding technology outlook. So on the left here, you can see where we think we are from 23 to 25 to 2035. So at the minute, we think about 45% of the market in 2023 was hairpin. That's seen substantial growth over the last few years. Lots and lots of platforms coming online in the last couple of years of running hairpin. And that's really taken the market from insertion. So you can see insertion now being squeezed to not far off an equivalent number, just over 40%, we think, or just shy of 40%. But you can see as we move through the years, growth of hairpin, we think real substantial growth over the next 5-6 years out to sort of the end part of this decade. Then it begins to sort of flatten off, which is where we're sort of trying to see, you start to see the purple bit walk in there, continuous S wave. We think that has got some real traction in this market. I wouldn't be surprised to see that eat more of the sort of yellow-orange segment there. And we see even more of a reduction in insertion as we move into the next decade. I think, like I say, our going in point at the minute is we're not sure whether that will be hairpin or that will be S-wave, but I wouldn't be surprised to see continuous take a big chunk of that insertion from, say, 2030 onwards. At the top, you can see X-pin. So at the minute, we think it's a couple of niche applications in China, but again, Don't be surprised to see that walk in bigger volume as we get towards the end of this decade. Certainly what we're keeping our eye on, particularly on continuous and on XPing, is how the first launch or two of those generation of motors go. If they go well, if they're successful, if the performance is very good, don't be surprised to see those grow in the market as we get into the next decade. So in terms of hairpin, that's going to be the biggest one. We think you can see nearly 70% by the time we get to 2035. Where's that growth going to come from? Last year, it was Greater China and Japan, Korea, and predominantly that was Japan in that segment there in the purple on the right there. But you can see this growth coming in Europe and this growth coming in North America, to the point that, you know, that they are pretty substantial markets by the time we get to 2030. So we're seeing a lot of investment. We're seeing a lot of tooling up of lines to come online, certainly here in Europe and certainly in North America. You can see by the time we get to 24 to 25 is quite a substantial jump in both regions. So in the next year, I think we will start to see a lot more production lines come online running hairpin windings. E-motor speed, so another way in which you can potentially reduce the mass of your motor is to increase that maximum speed. Traditionally, we've seen the market try and limit itself at about 20,000 RPM. Once you go above that, there's some performance drop off. There's some concerns around, do you need to run different bearings? Do you need to fit different technologies to the motor? But we're beginning to see more of a push towards this. Again, as I said, reducing that mass of the motor is quite an important part, particularly around, you know, reducing some of the material content. So we're starting to see this approach of just creeping above 20,000 RPM. At the minute, the maximum speed we have in our forecast is 25,000 RPM. Certainly, if you look at a couple of suppliers here in Europe, but also in particular in APAC, there is some suppliers really coming online who are planning to push this, I would say, upwards of 30,000 RPM. Some have mentioned, some going beyond that. At the minute, we are clipping it at 25,000. We think that's about where the industry will push it to in terms of a mass production at the minute. Again, though, improved cooling, improved performance out of the motor may see this stretched even further, cooling being the critical one there. But in terms of that market, we think right now it's about 2% that is 20,000 or above, and we think that will grow to 23% in 2035. So a lot of suppliers and a lot of OEMs going down the approach of 20,000 plus 20,000 plus RPM for eAxle based motors. Another technology that we're seeing, and this is more around the use cases of the EV, but it's a way in which we're seeing suppliers in particular pivot the technology that they've currently got that will meet the use cases of different requirements, different vehicles, as we see electric vehicles grow into different segments. So you take a look here in 2023, we're pretty much all at car and SUV for the EV segment, a very, very small van segment there. But moving forward, as we transition through the next 12 years, a bit of an aligning issue there, but you can see 14 million eAxles will be fitted in 2035 to vehicles that aren't cars or SUVs. So something that we were traditionally driving the passenger car market. That's going to present a real opportunity for suppliers, we believe. And why do I say that? There's different requirements. So let me focus in this particular example on e-beam, on the pickup and the van segment. Towing capability is really important there. You've got big payloads or big towing weights. You need to shift these. How you then run your eAxle motor, traditionally, you would require more continuous power and continuous torque as opposed to looking at that peak power. This is where e-beam comes in. So e-beam it can be fitted to it's a solid beam axle with the electric axle, I guess, fitted to it. So vans and pickups, we think just shy of 11 million drive units fitted to these by 2035. At the minute, our market projections say that about 1/5 of this, give or take, will be e-beam units being produced. Mostly at the minute, that's around where we think the suspension geometry will maybe be fitted to these. But clearly, the total addressable market for this could, in theory, be 10.9 million if every van and pickup ran suspension that made this compatible. We think this is going to come really in North America and in the pickup market. So you can see there,
The North American market is, nearly 3/4 of the e-beam market. And the pickup market there is, it's about 80% of that in North America. In China, we are seeing growth now. We are seeing lots of announcements of suppliers winning business in Greater China with certain OEMs. And then there's a small section there in South Asia. That's really tracking India at the minute. We know there's a program been announced with Mahindra. And don't be surprised to see South Asia become more of a market for this as EVs grow into South Asia. We think there could be a real market for this technology there. This is, as I say, a supplier-based technology in a minute. We think this is one where suppliers will do the full axle and eAxle assembly. So they will supply the shafts and the full complete 3-in-1 system, say, for the eAxle. So e-beam is certainly something we've got our eye on, and certainly something that we see as a different use case. Suppliers reacting to a different use case for electric vehicles. Efficiency. I touched upon efficiency a little bit. This is the king buzzword that we hear at the minute from suppliers. As I said, anything you can do that has a knock-on effect on the battery, provided it's cost sensible, do it on the motor. That's generally what we're hearing. So where are we at the minute? We think, and we've analyzed 2 suppliers here who have all 3 machines within their portfolio: induction motors, externally excited, and permanent magnets. So the red line here is the peak efficiency. This is what we're hearing is about, we think, the peak of what you can get out of these machines. And this is just talking to suppliers. So we could dispute it and say you maybe get 1% more out of PMSM. This is sort of an average of what we're hearing from different suppliers. We think supplier 2 has probably achieved its peak on PMSM. They might argue they can creep a couple more % out of this. The average of what we're hearing is about 98%. We think EESM is growing in terms of its peak efficiency. We think that can get to about 97%. And I'd say the improvements that we're seeing on EESM technology are pretty substantial now. Certainly there's a view that it may even be equivalent to PMSM, and supplier 2 are approaching that. What are they, 1 or 2% away from them? Some say that they've reached parity with PMSM on peak efficiency or drive efficiency, depending on what they've really focused on. And then there's induction motors. So induction motors are going to be really important, we think, but particularly around secondary eAxles. So again, I'll focus on that. I'll touch on that in a little bit. But secondary eAxles, so all-wheel drive, 4-wheel drive systems where you run a primary axle of permanent magnet or externally excited to gain that peak efficiency and the operating window where those motors are really efficient. We think you will run potentially, or at least the market is trending towards running induction motors as its secondary eAxle. It gives you a different efficiency map, shall we say, different benefits on the duty cycle. So when you run this through a WLTP, you're gaining the efficiency. If you run a disconnect system, you can run the induction motor where it reaches higher efficiencies than permanent magnet, say, and then switch onto the permanent magnet when you need that efficiency. So looking at the system as a whole, like I say, trying to improve that drive efficiency to then bring the motor cost down. There's also a little comment there, silicon carbide based inverters. So, I said I wouldn't touch on it too much, but this is something, again, another trend we're seeing around the e-motor where we think the shift to 800 volt will drive silicon carbide for the efficiency gains you can gain on the inverter within the system as well. So the type of e-motor, we touched on EESM, we touched on PMSM. So these are the 5 types that we currently track within our forecast. So axial flux, claw pole synchronous, which is really a hybrid technology, current excited wound rotors. So some will call it externally excited as well, the EESM ones that I've just mentioned. We have interior or surface mounted permanent magnets. So let's just call it permanent magnet. That's really the dominant choice at the minute in the market. And then induction, which I just touched upon there. I won't go through all of the ins and outs of these. I'm sure you know it. If not, you can read the bullet points here, or even come and ask me afterwards if there's any questions on this. So again, where do we think these sit? And again, efficiency is the king. So in terms of this, permanent magnet, peak efficiency, as we just saw on that slide. EESM next, induction motors, and switch reluctant motors as well. Here is another one that we've kept our eye on, but we don't think will come to mass market. We're not particularly tracking that specifically in our forecast. Reliability of motors, I would say they're all pretty good. Technology maturity,
ESM, if anything, I would say we're probably approaching the point that this has shifted now to a 4 or 5. I think there's enough OEMs and enough suppliers willing to use this technology that the maturity has probably reached the point at which we can take this into mass adoption, and we can really start to ramp the volume up, which we are currently seeing. So what does that look like on a global scale? And this is, I should emphasize, this is global, this view. We'll touch upon it regionally on the next slide. You can see permanent magnet, interior permanent magnet remains dominant. This is for eAxle based motors only. Again, let me emphasize that, eAxle based only. But you can see 74% of the market, we believe, by the time we get to 2035, will still be permanent magnet. There is an element within that of a Tesla-like approach where you run a non-rare earth-based magnet, but we don't think that will be a huge market. We think that's more for sort of entry-level vehicles where you're trying to get volume up and maybe performance isn't as important. Some investment from GM and Stellantis, I'll touch upon that a little bit later. But we can see this growth here of yellow, which is currently excited, EESM, and then this purple one of induction motors. So we are seeing growth in those two. We do think there is a reasonably big market there. You know, by the time we get to 2035, a small amount of axial flux. So about 25% of the market in our baseline forecast is for either EESM or induction. But let's break that down, because as I mentioned right at the start, China is kind of leading the way on electric vehicle production. We think that they will still have just shy of 40% of the number of EVs produced in 2035. So let's break this down into the 3 key regions. You can see China, interior permanent magnet. We see no reason for China to shift away from this. They have the materials, neodymium, dysprosium, terbium within the magnet. They also have the processing technology. So we see no reason for Greater China to shift away from this technology in any real substantial volume. You can see there's a bit there of induction. That's really a few suppliers there, Hasco Magna being one, who are running induction motors. Again, on your secondary eAxle, still there's an efficiency gain on a duty cycle, so there is a reason to do it. But it's Europe and North America where I want to focus on, and Europe in particular. Europe, you can see by the time we get to 2035, we think we'll be approaching 50% of motors being produced that aren't permanent magnet based. They will be externally excited, currently excited, or induction. Induction, as I say, this is coming on secondary eAxles, so all-wheel drive, four-wheel drive systems. EESM, we are focusing in on a few big OEMs. So I mentioned BMW, I mentioned Renault. We think there's a lot of others explore. Well, we know there's a lot of others exploring this. I would not be surprised as we move through the next decade that this number does not grow even more. I think we're seeing a lot of suppliers develop these technologies to have in their back pocket. There is a real concern that there could be some, that we could have supply chain constraints on permanent magnets. And therefore, I think we're seeing a lot of suppliers develop this. We're seeing big performance gains. You saw the earlier chart on specific power. Big performance gains on EESM. We're hearing from a few suppliers that they believe that their performance of EESM is kind of now even rivaling permanent magnet. I really would not be surprised to see this number grow even more as we go through the next couple of years, as adoption of this becomes more mainstream. In the US, slightly different. We think more induction motors there. That probably comes from the fact that there will be more all-wheel drive and four-wheel drive systems, we think, in the US, pickups in particular. So we still see a market for permanent magnet there. We think they're beginning to set up their own supply chains. If we take Vacuum Schmelzer and General Motors, they've got their partnership to supply magnets, to GM. We know that they're setting up a plant in South Carolina to do that. So I think in the US, we maybe still see permanent magnet. It's where those magnets are coming from. And I think there will be more of a push to bring those into the US. We do think there's a market there for those non-rare earth based, certainly the Tesla announcement. We think GM and Stellantis are investing in that as well. So the US, we still think will be a magnet-based market, really. But you can see that growth of induction that's really coming there. So critical materials. So we said we'd touch upon this. This is some new research we've got. So let me first focus on neodymium. So what I want to do here is give you some scenarios. So what we did when we walked this in was said, okay, 100% of the market is neodymium. So we believe every motor on the market for outside of Greater China is running permanent magnet. Therefore, it has a level of neodymium within it. I should emphasize, we have not within this tried to look at all the great work that suppliers and designers are doing to reduce the content. We have taken an average content for a power rating and kept that applicable throughout this forecast. So we're not trying to look at what different suppliers are doing and, 1 or 2 gram savings here and there that we know is happening. We've taken an average across the supplier base. We think our baseline scenario that I've just presented gets us 15, 16, 70% by the time we get to the end of the forecast reduction. So a reasonable chunk taken out just on that baseline forecast and the growth of EESM and induction. But let's take the secondary eAxle market. I touched upon it a little bit over the last few slides. Let's say that from today or from last year, every single secondary eAxle switched to non-rare earth. And let's call it induction because we think that's the market there. But for the purpose of this, just non-rare earth based motors. So we focused on induction. It could be permanent. It could be ESM as well. We think that by 2035, that would get you approaching 30% reduction in neodymium just by switching your secondary eAxle and taking the baseline scenario that we've got would get you to about 30% reduction in neodymium. So the baseline reduces about 19%, another 10% with this. So a relatively straightforward thing that the market can do. We know induction motors are there. We know that there is a performance gain if the market switched suddenly and everyone did it. We think that's the potential gains or the percentage gain you would gain in neodymium throughout this forecast. Let's take the next one. So let's say that, and I touched upon here, non-rare earth based PMSM. So these sort of ferrite based magnets we think, and now there's a few other different technologies, but let's call it ferrite for now. Non-rare earth based magnets. And we've gone this into what we call the entry segment vehicles in Europe and North America. So A, B, and C segments with really low power motors as primary drive. We think that could get you another 3%. So this is, like I say, the Tesla approach of non-rare earth based magnets. We have pitched this scenario into what we consider entry level vehicles, the lower segments, the lower power motors, where maybe if performance isn't as important, you are just looking to get volume and get EVs sold, which is probably what we're going to have to see in this next decade anyway. So what about copper? I guess this is quite relevant to this audience. So copper usage in motors, here's where we pitch it roughly at the minute based on our research of PMSM versus EESM versus induction versus axial flux. EESM sits at the highest. The key reason for that is you have copper within the rotor and within the stator. So regardless of the winding technology you choose, there is copper within both the rotor and the stator that is not within permanent magnet. So we do know that there's technologies coming to try and reduce the levels of copper here, reduce the quantity of copper. Cooling, again, is a really important one there if you want to do that. But right now, this is sort of the bandwidth in which we think these technologies are operating in terms of their copper quantities per motor. So what does that translate to for eAxles in terms of a copper requirement from the eAxle market? We think we're approaching around 600,000 tons by the time we get to 2035. Again, we haven't tried to focus in here on, well, this cooling technology will come, which will reduce a content of copper by X amount or anything like that. We've taken an average now and extrapolated that across. So that could chip down as improved performance, could go up. If EESM takes off even bigger than what we think, that demand could go up. I know speaking to Fernando at a recent conference, he doesn't believe there's any real supply constraints around this. We just wanted to show the demand. I think I was talking to a few people recently. We expect the motor to be somewhere between about 5 to 7% of the total vehicle requirements for copper. So if you think that, let's take it on its lower end, that 5% is 600,000 tons, you can start to put into a quantity of how much copper is going to be required on a vehicle, on an electric vehicle. So that's where the motor sits at the minute. We think that's our initial assessment. There's a bit more work that we're going to try and do to refine this, but I just wanted to showcase our initial assessment on copper demand and then do that regionally. So where is this copper demand going to come from? At the minute, you can see big demand in Greater China. We think that will slightly reduce as the share of EVs produced in China begins to reduce. North America will see some growth. Europe will see some growth. Europe mostly around its ESM machines. The US, or North America, should we say, really coming around the higher powers that we think are going to come into that market. But just to give you a feel of where we think this copper demand is going to be. And I won't run through this in too much detail and go through more, but this is just to give you a summary of what we think is happening on the materials market. Significant investments. Let me just focus in on that one at the bottom there on the red in North America. GM and Stellantis. Magna have recently invested in this company as well. Niron Magnetics is non-rare earth-based magnets, non-rare earth-based motor materials. We're seeing investment in those. Like I say, 2 big OEMs in the US, plus a big supplier coming out of the US investing there. Lots of e-steel plants, lots of e-steel production being set up globally. We focused on this outside of Greater China just to give you a feel of what we think is happening in these markets outside of Greater China. So where does the supply chain fit into all this? So let's take the 4 components that we track within the motor. So this is the system integration, so who integrates the eAxle. This is the motor assembly, who's producing the motor, the rotor assembly, and the stator assembly. So we're looking here for OEM vertical integration. So this is looking at someone like Audi's ambitions, BMW's plans, which is they will do the integration of the eAxle, the motor assembly, produce their own rotors, produce their own stators. We think in 2023 globally, that was about 42%. There's some big OEMs within this, the likes of BYD, who have full vertical integration through FinDreams, that are keeping that number relatively high. Jump forward 7 years, we think that number is going to reduce. So there is going to be more supply chain getting involved into this in some form, and where that is, we'll go through next. But we think that in 2030, sorry, that will be about 34%. Full OEM vertical integration for those 4 elements of the system. So let's go through these production levels. Let's try and break this down quickly. So system integration. So this is who assembling that 3-in-1, 4-in-1, who is doing the assembly of the eAxle. Taking 2030 as the reference, we think 68% of the motor market of the eAxle market in 2030, the system integration will be done by the OEM. 68% of OEMs will do system integration. 68% of the volume will be done by the OEM. That's around, we think by the time we get to 2035, it's about 60 million units. But 68% of the market, the system integration will be done by the OEMs. Let's pull that to the system plus the motor production, so the motor assembly. The numbers come down to below 50%. So there's a portion within this orange segment here that you can see on screen now. That's a supplier going into the OEM. So that's an OEM who's not prepared to do the motor assembly themselves. They want the expertise of the tier 1 supply chain. So 55% there, at least on the motor side, is going to be done by the suppliers. So there's a good opportunity for suppliers on the motor. Let's break it down then even more for rotors and stators. So like I said, we were at 34% for the supply chain, keeping that fully in-house. So there is big opportunities, not necessarily completely on that system integration of the complete integration of those components, but being flexible. I said it at the start, flexibility is the buzzword that we're hearing so much from suppliers now. We need to be flexible. We have production lines for rotors. We have production lines for stators. We need to keep them as best we can to 100% capacity. If that means we have to pivot and supply an OEM with just our rotors or just our stators, or print to build rotors or print to build stators, we're seeing more and more tier 1s be prepared to pivot towards that. And we're also seeing tier 2s. So if you're a motor core supplier, we're seeing the first rumblings of those suppliers looking at this going, there's an opportunity here. Do we expand our business and become a tier 1? Do we do the full rotor? We're producing the core at the minute. Do we expand that, do the full rotor assembly and go direct to the OEM? So it's an evolving market. We're seeing lots of different dynamics. Flexibility is the buzzword at the minute. People are having to be flexible in pivoting their business models. So let's look at the in-house outsource of the motor, the inverter, the system integrator. And I want to focus on the blue segment here, which is equity alliances. on the e-motor in particular. This is really been driven in Asia at the minute. So Japan, Korea, and South Asia. I'll show you the breakdown in a minute. But you can see the motor, there's a split, should we say, between in-house to supplier-based. And supplier-based would be within the equity alliance and strategic sourcing. So equity alliance, as it says, is where the supplier and the OEM, there's some monetary, exchange involved there. There's an equity. More than likely, the OEM is investing in the supplier. Big model, like I say, in APAC. On the inverter, it's more of a strategic sourcing system integrator. You can see it's a big, big market for OEMs doing this in-house. So let's break that down on a regional strategy, and you can see where we are in 2023, Japan and South Asia. We've got these first rumblings of equity alliances here. Predominantly, like I say, this is in Japan, that Japan and Korea section. But just look at how that's going to explode over the next 12 years, we think. Even here in Europe, even in North America, we think there is a degree of equity alliance within this, where the OEM and the tier one are partnering up, and there's equity involved, but it gives you your into an OEM, and then they can leverage you for whatever part of this they want. Really big in Japan and Korea, really big in South Asia. So if you are a supplier looking to work in some of these markets, this is how the dynamic we think is going to evolve, certainly on eAxles over the next sort of 10 to 12 years. And a quick summary from me. So the eAxle market is going to grow rapidly. It's coming. Electric vehicles are coming globally. We think the total eAxle production will exceed 85 million units by the time we get to 2035. Technology and performance trends are really critical at the minute. Power density and efficiency are two of the hot topics that I've gone through here in terms of motor design, and some of the technologies that we're seeing OEMs and tier ones use to try and improve these. Permanent magnets, rare earth-based magnets, are the most efficient choice. We expect them to remain within the market, but we are seeing supply chains look to tackle or look to put in place preventative measures for potential supply chain challenges that may come forward in the future. ESM being one of the ones we're seeing here in Europe. Larger OEMs continuing the trend of vertical integration. Like I touched upon the numbers there, I won't go back over them, but we still think around 60 million eAxles in 2035 will have some supplier involvement. That could just be the rotor, that could just be the stator, it could be the full system. I touched on it there, the subcomponents, and we're seeing this on the inverter as well. This isn't just exclusive to the motor, we're seeing it on the inverter. Subcomponents are being really critical. The OEMs are bringing the design in, they're bringing the design of these components and the integration of these components in-house, but they're happy to do either a supply chain or a print to build subcomponents within these. And then we touched upon use cases. Use cases for EVs are going to differ. The wider this market becomes, everyone has different requirements. So we will see technical solutions come to the market, and I've touched upon a few of them here, for cheaper motors, for affordable vehicles, for different heavier vehicles like pickups and van markets. We will see different use cases and different technologies come to the market. On that note, I will end the presentation. If you do have any questions, please raise them now if there's any, or my email address is there if you want to connect offline as well.